So we will learn about the achieving a high availability in PostgreSQL. So we will discuss some strategies, some tools and best practices, how we do achieve the high availability at PostgreSQL. So my name is Ibrahim. I'm a SQL engineer in PGS. That's so. So what's coming to your mind when you talk about what is the high availability? So the main thing is that your database is up and running up 99.999% of how many nines you can put there. So it's amazing. So that's the main purpose of that. It's like if you have one computer that it can run reliably, it can perform 99.9% or 999%, so there is no need for adding another computer or failover or something like that. But it's not possible because it's in hardware and it's a software. Hardware can also crash and damage. Software can also crash, has bug, maybe some other reason. Then we have some tools, some strategies to achieve a high availability. And that's called the operation continuity. You need operation to continuously work because you can have sensitive data. You have sales terminals there. You can't afford that the sales terminals are down. You can't see the printed in your shop. It's a medical emergency. Anything can happen. So you have to ensure your operational connectivity. Again, it's like redundancy. So your data should be redundant. Like if you have a data in one computer, it should be redundant. So it's kind of a backup or the replacement server. So it can be anything. So data integrity, failover, that's the technique when you come to the high availability is come to the point. So the last point is monitoring. You have to monitor is your database is available or not. So you have to continuously monitor. That's the major thing to have to care of the high availability. So when we're talking about the high availability, the first thing is the replication. That means your data is replicated in multiple nodes. So you have one node. Whenever I'm calling the node that means under database of PostgreSQL server. So you have one node, so you need to replicate your data to another node. So now you have two nodes. So you see that you have one node and you have another node, and you have three nodes. So that's required an replication. So that's the major thing. Because I don't need it happen when you have on one computer and you want to achieve a higher availability. That's not possible because it's hardware failure or software failure can disrupt your availability. So you need to replicate your data. So like if you insert some data in one node, it should be available and but more than three nodes. So that's availability of your hardware, how many hardware you want to add into your network. So that can fail over. One thing is you have to keep in mind that PostgreSQL only provide a single master multi-replicas. That means it's the one server where you can read and write. And all the replicated server, you can only read from. You can't write to that. So when the read replica fails, so that's not a problem because you have other replicas or you can use from the original a primary. So to have a primary node, you have a secondary node or replicas. So if your replicas fail, well, it doesn't matter actually. You can connect to your another replica or you connect to the primary and you can get your data. But the problem is that when your primary fails, so there is no way you can write to the replica. So here comes the failover. So the primary fails, then one of the replica will become a primary. So on that primary, you can read and write. And all the replicas are become the replicas of that batch. So then the load balancing, when we are talking about the higher visibility. So load balance is important because I told you that you have one primary and you have multiple replicas. So you can balance your read load. Just have a concept that you can write and read on the primary node but you can read from all the windows. But here is a need of load balancer. So it can be our software, a middle software, which PG Port provide that. There are other tools are available. HA proxy can also do that. The connection level load balancing can cover that. So you can say that first query, first connection to this, second connection to this, third connection. But the right connection only to the primary node. So load balancer, you require load balancer. And the connection polling. PostgreSQL, there is a problem. When you connect to the PostgreSQL, you have thousands and thousands of clients. But usually your thousands of clients are not continuously connected to the PostgreSQL. Some are querying the PostgreSQL or some are the idle connections. So they are not querying or they are connecting the PostgreSQL and dropping the connection. So you need a connection pooler in between. So it connects to the PostgreSQL and whenever the connection is needed to the client, it will throw that connection. Otherwise, it will pull that connection. So it will not put the load on the actual PostgreSQL. Saying that you have monitoring and management software, you monitor and manage your software, like it's, there is a need of hardware, you may monitor your hardware, that hard disk space is low, memory is 100%, something like you monitor your database. I think the hardware. Then you can change that, you can manage your thing and backup for recovery. So I told you that you have the replicas. They are somehow your backups. Because you have a replica, you already have your backup on that one. But still you need a backup which is electronic network. That's important. Some people confuse with replica with backups. Because sometimes happens your old network is compromised and somebody has reached your old network data. All the credit. So what people are doing, they take a backup and put the backup in somewhere else. So it's safe. Whenever something happens to all the network, right? If you have kind of a server which has some virus or something like that, the whole network is down. All the replicas are down. So where will you get your data? So you have your hard disk or something, S3 space, hard disk, you have saved your data as a form of backup. So backup is also important. Then we cluster group multiple server into one. So we will discuss one backup. These are the main items we will discuss in 30 to 40 minutes. So this is the diagram. I put that you have nodes, you have a backers, you have a PG bouncer, HA proxy, and this is the picture. We will connect this picture. At the end, we will connect all these things and become a one big picture where you can see your primary, your replica, your backup, everything you can see here. PostgreSQL replication. When I'm talking about the replication, PostgreSQL provide actually two types of replication, and a physical replication and the logical replication. And physical replication have a streaming replication, asynchronous and asynchronous replication. So these are all the physical replication. So generally it's logical replication and a physical replication. When we are talking about the physical replication, that means the whole node is replicated to the another. So whenever you do something on primary node, it will be replicated to the replica as it is. So there is a physical replica. So the whole node is replicated to the another. And when we are talking about the logical replication, you have a granularity level to the table that you want, and this table is only replicated to the another. So you can specify that this table replicate to the this one, or this table is replicated to these many sub. So in that case, there's a difference. The physical replication is whole cluster is replicated to the another server. But in logical replication, you have a granularity level of table that it will be replicated to the another server. So here, the actual physical application, I will not go to the detail. If you have any question, then I will answer that question. So normally when you say that there is a read-write in PostgreSQL, this is the primary server. And Postgres can have a wall, right, a headrow. So it has a two process, a wall sender and a wall receiver. So primary have a wall sender process. Whenever you write something, the wall is written to the disk and the wall sender will send the wall to the replica. And the wall receiver will receive and encode that and put that into the replica. So it's applying that. So continuously you are writing to the wall, and wall sender is sending to the wall receiver, and wall receiver is receiving and applying that to replica. So that's continuous process is going on. And that's the physical replication. It's kind of a blocks are traveling between the network. So, but when we are talking about the logical replication, you have a model of publication and the subscription. So now you are not replicating all the node, all the databases. You are only replicating what you need. So right now you have a wall which has a logical decoder, which is decode the wall and the subscription pointer. So you subscribe to publish your table. So write publish my table, and then on the server it will receive that publication and apply it. So that's only a table map. And the important thing is you have to keep in mind that it's two-way. It's not like these two servers are both the primary. You can write on both of them, but data is synchronized between them only on that table, which is publication and subscription. They have publication and subscription. So there is no primary replica concept in logical replication. But they both have read-write node, but data is replicated between nodes just when what you have specified in the publication and subscription. So, oops, yep, can we repeat it variants in the source? But John, if you want a GTL changes to be replicated, actually there are some solutions like CGF. We have that studio, but that DDL also replicate. We are using the logical replications to create a distributed database system. So we are doing that, but it's not in a Postgres. So I'm not going to the detail of that. In physical application, you have an asynchronous replication and you have a synchronous replication. So in asynchronous, you just write your transaction and just it will write to primary, and on replica it will write afterward. So you will get the reply that it's written. So that's it will give you the speed, but the reliability is not sure that it's written or not. It will give you after it's not written and you're getting some error in that. But in synchronous, you write on the primary and it write on the replica, and then other replica. If you have 3 replicas, 4 replicas, you write on all the replica. When it got the reply from that replica, it will say, okay, 5%. So that's the only difference. Then you write it, you get the response. That's called asynchronous, and the write will happen afterward. But in synchronous, you write it and you wait. All the replicas have applied their changes, and you will get the reply. So that's the major difference between the synchronous and asynchronous application. Here's on the active-active. When I'm calling the active-active, that means multi-master. So I told you the Postgres will have primary and secondary replication, right? Primary and replica replication. So you have a primary node where you can read and write. You have a replica node where you can read only. But there is a concept of multi-master replication. I will tell you how you can achieve that. There are some problems but you can achieve that. How you can do that? What is the active standards? When I'm talking about the standby, replica, slave, these are all synonyms in Postgres. You can call it slaves, you can call it standby, you can call it replica. I usually call it replica, but some people call it a standby. So one primary and more replicas are standby somewhere. And once in activated, multiple parameters. So what does that mean, multiple parameters? That means you can write to multiple systems and they are synchronized. That's very important. You can have a one primary, you can have a one primary, you can read and write over that. That's not a problem. Problem is when you have a two node and they are connected to each other. And now you can read and write to the boards and they are synchronized. That's called a multi-master application. Because when you call them multi-master, that means there are two masters or three masters, four masters. So there is a bi-directional application? Yeah, that's bi-directional application. So that's a multi-master, bi-directional application, active-active vertical application. So all these are the same.
Where's the application with that?
Sorry?
Where's the application with that?
Application for that? I will tell you in next slide. There are applications. So many applications here. Right, I'll get to the quick example. You have your one server in US and one server in Europe. So one is primary and one is a replica. So where you will write from Europe to US, continuous you're sending traffic to US. And lag time, everything is important. So if I give you the library, then Europe server can write their data in Europe server, and US server can write their data to the US server. And US and Europe server are connected to each other. That's the benefit. Speed, everything. And something is broken in between the networking program between America and Europe, but still they can use this server. When they connect again, they synchronize. They sync the beam. So you will not lost your information or something like that. So in active standby, it's a load balancing. I told you the load balancing can achieve that. You can read on multiple. You can read to the primary, you can read from the replica. So load balancing can be done by using the external tools, or you can write the logic in your application. You can write the vertical application, your first connection in to replica 1, second connection to replica 2, third connection to the primary, and write always go to primary. So you can write the logic in your application too, or you can put some PG4 or something like that to it in between. So I told you that's not part multi-master application is not part of the PostgreSQL, but I will tell you it can be possible in Postgres. So here the main example of multi-master application. You have one client and you have read and write connection to processor, and I have not put the connection between two. That's some logic, because this is not possible in physical application. In PostgreSQL, physical replication does not support multi-master. But I told you, in a logical replication, you can create a publication in one node, and you can create a subscription node to other node. What I will do, I have on a table test. I will create a publication here in one node, subscription on another node. And here on same table, I create a publication on this, on test, and a subscription on this. So whenever I write on test, it will go to here. When I will write on this, it will go. That's a multi-master. You can write on both the disks, on node 1 and node 2. So here, if I write to node 1, in using the vertical application, here we have a publication, we have a subscription. We have a publication, we have a subscription. So bi-direction is possible.
Does it work with foreign key?
I'm coming to that point. You can do that. I told you it's not in PostgreSQL, but you can do that. But you will face problems. You have to handle that problem. So the first problem, simultaneously data retrieve. You can write the data. So problem arise between the conflicts. You are writing to one, Another one is that query tables. So when they collide, so it's configured. Who will resolve that conflict?
Nobody.
But you can do that, but you have to fix that these blocks, right? So load distribution, definitely you can do load distribution. So you are putting right loads to both the loads. That's the way. So for the real-time data synchronization, geographical distribution, you can do all these kinds of stuff. But the problem is major, which is conflictor. Not only the conflict resolution, there are all other problems are there. So if you can manage in your application, that's possible. I told you, how is that possible? You are not creating a publication and the subscription of same table. So, like you have a test table here, and you have a test 1 table. So test 1 table replicate to the node 1, and test table is replicated to node 2. So it works. There is no conflict. Still you are doing the multi-master, but there is no conflict because these two tables are different. So it's possible, but if you do them the same table, same database, so the conflict, the problem, you have to fix that. So the same thing actually we are using in a PGA. It's an open source. One thing is that the PGA is open source. You can go and download. It's available on GitHub. The Spark extension, we call it the Spark extension. So where it's possible, we are doing the conflict resolution. Everything is done automatically. So you can achieve it. You can publish your data, you can subscribe your data on both sides, and it will replicate on the data into the conflict data. So the connection pooling. So it is an example of connection pooling. You have like I created a lot of laptops and connection here. You can see it can be thousands of connection. Like on the website, thousands of people are browsing at a time. So it has to pick data from the database. So if I have a PostgreSQL server and it can only handle 1,000 words or 1,500 words, so how will it handle hundreds of thousand connections at a time? Postgres can't do that. So in between, we had another node. So we can install PG Bouncer, PG22, Patishcat. These are 3 OLS available, and these are free open source software. So you just install them, and now you connect to that. You will, and this the brown color shows when the PG42, PGCat, or PG Bouncer. So the client will connect to the PG42, PGCat, or PG Bouncers, and that will connect to the Postgres. All right, and you can configure your read load will go here, your write load here, everything you can configure. But there are some limitations in one software that can do that, other. You can experience these tools with that. So reduce connection overhead. I told you, if you connect to your app, configure your Postgres to handle hundreds of thousands of connections, it won't work. So it will reduce the connection overhead. Second, enhance scalability. Definitely is enhanced scalability. That you have PG pool, you can have a multiple PG. You can have a multiple PG. So its scalability is good. Performance, definitely performance in good. So if you have the like PG pool 2, I've been talking about the PG pool again and again. But PG pool also provides the load balancing. It's also doing the coding and also doing the load balancing. And pooling solution, I told you, different pooling solution is available. Not only one, PGCat, PG Bouncer, and each. So you have a multiple solution for that. Now, here are some other problems in high availability. Which is actually outside the Postgres. So we talked about the replication, we talked about the pooling. These are the problems, but there are not some problems. PostgreSQL does not provide automatic pay-to-write. So when your query fails, there is no plan. There is no plan. you have to promote your replica as a brand. Yourself, manually. So, what are these solutions? So there are some solutions over here. One thing is you continuously monitor software, you promote the replica whenever it's but it's not possible for a human, or you can try the scripts, taking the PostgreSQL and checking that it's alive, and you do that. The other thing is there are some software, like Python. That's a Python code actually. It's written by this Zomato. So you can use it to configure that the PostgreSQL, it manages your cluster. So it's similar physical application. Now we are not talking about the logical application. It's a physical application, and this will manage your physical cluster. Like one practice, multiple replica. It is managing Patron is managed. So whenever your primary fails, Patron wake up and create one replica to make it upright. So how it will replicate any replica into brand? How it will decide? There is another protocol. That's a forum-based protocol. That's called XCD. You install XCD on all of their nodes, primary, on all of their replicas. So they do an election, in a forum-based election, which will be the next primary. So your primary is down, so they will elect another primary, and patroning will be that primary. Right? So you have that setup, that election is happening, forum-based election is happening, new primary is elected, now it will complete track. So we already discussed the PQ Bouncer and the PQ 2. The failover, you have Adino, that's just change of color, and you have two replicas. So these are all connected. Alright? So there is a command that's called a PGCTL promote fantasy. This is reflected, and you can promote any replica to become a pack. So, and now Patron is gone. If you don't have a primary setup, you are going manually now. That's a tool, because we are discussing also tools and strategy. This is second strategy, that's a manual strategy. So you are promoting manually replica to the practice. So what can we do when we write PGCTL promote, server is down, that's gone, that server is gone, and the new primary is here, this one. Replica 2 is your new pact. So, what you need to do, you have to reconfigure your application. So now it should point to the new pact, because all the connection to this will end. And where your right traffic will go, it must be configured to go to the replica. That's another problem. How we will change the IP address of application immediately. So we will discuss another tool here. It will come in the final slide actually. We will cover everything about the tools and those. So minimum service disruption in that. Yeah, but here definitely that's the common term that availability configuration, everything you do that on the server, so it won't fail, something like that, connection boarding, load balancing, real-time monitoring alert. So you can just configure these are the just strategies to have the rules on your endpoint. So I'm not discussing in that detail, because it's there, the slides will be available, you can check that. So monitoring, how many types of monitoring available in PostgreSQL? Basic one is the logging. PostgreSQL have on a log. You can create a log, rotate the log, many basic error log, you can see your log. So it's available in PostgreSQL. Then it's a vanilla Postgres. And bringing stats good. That a PT stat statement, PT stat activity. So activity monitor, stat statements. So they are all views are available. You just do your views and you can get the statistics log. Performance dashboard stored PG icon has that kind of the tool that you can see the statistics and all. External monitoring tools are also available. Just Grafana, even the Grafana has the solution. The other companies have the solution for the monitoring tool. So you can use the external tools. Backup and restore. When we are talking about the backup and restore, the first thing is PG dump and PG restore. That's a logical backup. But I'm saying logical backup, it will create a SQL statement. It will create a SQL statement for your table and the SQL statement for the inserting the data. It's a textual based, simple text based representation of your data into a SQL file, and you run your SQL file, another database acting first. You know that in one client, they asked me to do the dump and restore to the database, and it's 7 terabytes. And I calculated the time. I told that it will take 7 days to take up backup at dump package. 7 days. And they were planning to do that every week. But just 7 terabytes, it takes 7 days. So we have other solution for that. So we're stuck in. The other solution is PG-based backup. But that's a physical. That's another problem. That's a physical. Physical backup, when I call it a physical backup, that means that will back up the whole cluster, a whole PostgreSQL node. You can select that PG-based backup only this database. No. But dump restore, you have an granularity level. So the tool actually I am recommending many people, that's the PG backup. Why? PG-based backup, when you're saying that take a backup, it will back up the whole physical node to another thread. But the problem is that if you want to do that after 1 hour again, so how much space you need? That means if I choose daily backup using PG-based backup and 7 terabytes, so in a 1 week, 7 into 7, 49 terabytes I need. But my changes are not 49 terabytes. It can be only a 4 GB, 5 GB. So PG backups provide incremental backup. So you take a backup like 7 terabytes and you just changes have 1 day only 2 GB. So second incremental backup, first incremental backup only 2 GB. 1, maybe less than 4 1 and be less. So PG backups have that kind of effect. So there is other tools are available. So I am not talking about the body, but the tool is there. So I just write it here and you can see wherever you go. So continuously archiving and pointed tab recovery. I just touched the pointed tab recovery. What is the pointed tab recovery? Pointed tab recovery is that you take a backup. Like if you take a backup 1 hour and you want to restore the backup, but you want to sync it with your original backup. So you can provide the timeline. So I want to do that till that time. Maybe you have a backup, you created a backup, but you have some problem afterward. And your backup is not restoring properly because you don't need some transaction before that time. So you provide the time, restore the backup till that. Don't apply that change which is after that time. So you recover your data till that. So that is called a pointed tab. It can be after that, so it will apply the new word on that. It can before that, it can apply before that time, apply also.
In the work also work with the PG backup first?
Yeah, PG based backup, PG backups, both. The wall concept is 100% same because that's a PostgreSQL concept. PG based backup also adopt that same concept of wall, applying wall, accepting PIT on PG backups segment. PG backups has many advantages, but the main one advantage is the three-factor backup. And good news is that till now PG-17 is coming with incremental backup. It's committed there, but I'm not sure in October, September, when they release 17, it will be there or not, but the patch on it. So, I'm talking about the PG backrest here. They do have an Postgres. So I talked about the incremental backup. So of course, PG backrest has incremental backup. So parallel processing that also do the parallel. They're just taking the backup happily. That's another advantage. So if you do the PG based backup, it will back only one code, when it can be stored. But PG backrest, it will use multiple process to get it happen. Why did that becoming PG-based backup also have the multi-tab becoming? So it's kind of big deal. So the both have. Compression, it has also a compression to can compress through database. And last one is really important. PG backrest provides us a way to take a backup, that's a physical backup, definitely, to the local disk. Definitely PG-based backup also have that capability, but it can take a backup to the S3. You can configure, don't take your backup on my disk because you don't have a space. Or I told you, if you take a backup on the same computer continuously, so if your computer is down or your network is down, so even your database is gone, your backup is gone. Sorry, no meaning about that. So you can directly configure PG backrest, take my backup to S3. So it will take the backup to the S3. So you provide keys and everything. You have configured your PG backrest scope. It will take a backup. So this is it that I was talking about. So what you have we will start from the US plus 2. And in red one, you see primary. Okay, and the blue one in a West 2 are the reader replicas. You have red one, primary, and you have a reader replicas. So, what I have suggested, you have HCD, this is the sign of HCD, you have Patroni. So, these three are the trigger to use Petron and maximum. And this is one node. You have one server with two reader replicas. So your client can connect. So in between, I put an HA proxy. HA proxy knows which one is the client. So it will your HA proxy has its own IP address. So your client always connect to the HA proxy. And HA proxy knows who one is the primary and who are the replicas. So whenever it receives a write query or something like that, it will not write query, some port base. So you on that port, you send the write queries to this, so it will send that query to friend. Similar to the queries to the replicas. So when the red one down, the read replica become a primary, the Sony will handle it, actually do the action, and it will become a prem. And HA proxy knows now who is primary now. So we don't need to change any IP address in line, and your client is working really well. So this is only one, and circling it, this is your one segment. And we generally call it is after one region. Then one region, you have one primary, multiple replicas, you can connect to them, seamlessly, failover, automatic failover is happening, you have an HA proxy, you have a load balancer, you have a PG bouncer, everything is done. But anything, if I replicate the same setup to another region, like US East 1, okay, and another one, US East 2. But the problem is that we have another one, that one, they need to be replicated. And if we do a logical replication, I told you it won't work. So there are a couple of solutions, not a couple of maybe 2 or 3 jurisdictions for it. The one is the enterprise they have their own solution, but their proprietary solution that the PTR or whatever they call it afterward. So they have, but it's a closed solution. Some PGI, we have our own solution for that. That's open source, completely open source. Then the extension is called for platform is a PGI platform. We call it a PGI platform. So it will provide this, the whole set. So these are connected now, is continuously there syncing to each other. And whenever something fails, then you have to, some replica will take over and become a replica and activate to connect to that another region. So now this is called multi-region high availability. So you have high availability within the region, you have a high availability in between the region. So that's the complete high availability.